Yeah, he has been one of the most aggressive and fun-seeking compost marketers we've had. Located in Pennsylvania, but serving a much larger area. So he is going to give us his lessons learned and the lessons now taught. Thanks a lot, Chuck.
Thank you, Bill. Thank you for having me. Chuck's fine, not a problem. Quick overview, NaturCycle, what we do, a little bit on how green infrastructure drives some of the lessons in the soil marketplace in the 21st century here, a little bit about using biosolids compost specifically within that green infrastructure. We'll talk a little bit about performance-based soil design, just to kind of give everyone a basis of education, and then in my opinion, why there's some superiority in some biosolids products for green infrastructure applications that obviously there's some debate and discussion going on about nutrients, things along those lines, but some of the issues I'm going to point out where there's some potential to highlight the superiority, the preference, the better reasons to use biosolids. NaturCycle, compost marketing, sales throughout the Northeast. Take a look at the website. Let's dig in a little bit to green infrastructure. So from a soils design and use perspective, for a very long time, golf courses, athletic fields, high-end applications used what they call performance-based soil design. They would tell you that the final soil has to have so much infiltration rate, so much organic matter, a certain particle distribution, versus what we see a lot of in the green infrastructure world, which is, okay, it's going to be a bioretention mix 25% topsoil, 50% sand, 25% compost. I'm not going to call that performance design. We'll call that like specifying of materials. Yeah, I'm not even sure what you'd call that from a design standpoint, where a USGA design for a golf course or a high-end athletic field like a baseball field or a professional football team, they're looking at the performance characteristics of the final soil. So if it happens to contain 15% silt and clay in the final blend versus 20%, that might be acceptable to them versus saying it needs to have 25% topsoil. So they're giving you an end goal to achieve versus trying to fit these narrow definitions of materials that might vary from area to area. And just looking at like New York City, that's their projected green infrastructure spending just on the green side for infrastructure. So rain gardens, bioswales, green roofs, that's their numbers put out by the DEP, 2.4 billion, and that's just one example of green infrastructure. So this is a growing market trend, it's a growing demand trend, looking at ways we can use engineered products like biosolids composts, Class A residuals like the Canby material in these green infrastructure applications. This is the place we should be looking if we need growth and opportunities to use these materials, right in our own backyards. So, quick definition of what is green infrastructure, just so we're all on the same page. I like this American Rivers Association definition where we talk about green infrastructure as being a water management plan that protects, restores, and mimics the natural water cycle. Leads us into what the natural water cycle is. This is what happens in a forest, a field, in nature every day. Most of that water, as you can see by the chart, is evapotranspirated or used in place. 85%, right? So the water never leaves. This is what happens in our built-up environments, suburban, urban. Most of the water, 50, 70%, is running off that site. Very little of it gets used in place. So what we try to do with green infrastructure is recreate that natural cycle. So we have green infrastructure. What is it? One definition is to create it from a variety of key elements. So you use these key elements to build a green infrastructure plan, like a rain garden or a green roof. It incorporates these key elements. It's got a small scale control. This is conceptual design, custom design to that site. There's conservation practices built in. These key elements make up that green infrastructure. So here's where the compost comes in. All those key elements can use compost and composted biosolids products or Class A biosolids products to achieve those goals. You can direct runoff with compost blankets and berms. You can have small-scale controls with a green roof. You can have custom site design with a bioretention basin instead of just stormwater abatement where it runs off to the nearest sewer. You have conservation by restoring habitats using compost. So those elements of green infrastructure are extremely dependent upon compost. Again, many of you are familiar with this, just one slide. What is compost? just so we're all on the same page, a humusy rich soil amendment made from decomposed organic matter. The key for me takeaway from a compost marketing standpoint is the controlled decomposition. It's making a product. It's not piling it up out back and letting it sit for 5 years. It's controlling that biological decomposition in the presence of oxygen to make a finished, stable compost product. Just an example of a biosolids product out of New York State. And as always, Compost Council is a great resource, a place to look for more information and quality compost products. Let's dig down and look at a couple of examples of the performance specs and the actual biosolids compost use. We'll look at one that's an amended soil in place using a biosolids compost. We'll look at another that's an engineered media, a blended product. So there's a facility in upstate New York called Delaware County, run by the county. That's a rotary drum MSW composter that also has Siemens ICS bays. It used to be IPS. Turned aerated compost process for biosolids. That's the product, very light and fluffy, popular soil amendment. This compost was used in a project in like the Yonkers area where the spec was a rain garden soil, where thankfully the engineer had designed performance characteristics versus specifying a specific mix ratio of ingredients. So that's a stormwater management tool, back to our green infrastructure points. The Delaware County compost, any compost, provides an important part of that mix. That's the organic matter. Some of the soil structure, some of the fine particulate could come from that as well. The silt and clay that are important to long-term plant performance. So this spec is the one I pulled out just as our example today to take a look at. They specified saturated hydraulic conductivity, which is a measure of how much water is infiltrating into the soil, the pH methodology, and the organic matter by loss on ignition. But the nice thing here is they just wanted ranges of the final soil. So maybe I got away by creating a soil that's got 20% Delaware County compost. Maybe it's 25. Maybe the plant type, they're putting a lot of grasses, fast-growing plants. So from a soil design standpoint, I felt that maybe we add a little extra compost to help get that plant establishment going. Where if they're putting trees and shrubs and more established plants, maybe lower your compost percentage to have a little less potential for runoff of nutrients. So here, you know, they spec'd 10 inches per hour or greater by that method of ASTM. The result for that particular blend, once the contractor took a sample of the compost and the soil on site, added the specified sand, sent it to a lab, was 23 inches per hour, which is greater than the minimum in the spec. Same with the pH, where the final pH fell out, and organic matter by adding that compost. So instead of pigeonholing the design around variable materials like quote-unquote topsoil, this design had the benefit of a finished result for the performance of the soil in place. Just some standard lab equipment. Not all this stuff needs to necessarily be that complex or, let's say costly. The nice thing here is that a lot of standard soil testing is not necessarily expensive. It's the designating the ASTM and being able to compare apples to apples that's so crucial. If you don't specify that ASTM for saturated hydraulic conductivity, there's like 9 others that exist. Some are more common than others. Some are more expensive, a test methodology than others. There's an old school one that's a rigid membrane versus a solid membrane. I mean, there are 100 different variations. But if you go in and design something with standardized testing, with achievable ranges, now 5 different biosolids end-use products might be able to go into these soils, because instead of pigeonholing it with a very particular lawn leaf compost, you've created an achievable goal based upon the characteristics of the materials. So here's the final result. He took the compost into the site, blended it with the sand to achieve the goal we worked on. Just a standard rain garden type application, maybe a swale, along the side of a building where the stormwater is runoff directed into. Just some examples of the planting. Again, you're seeing the sloping from custom site design towards the center where there's overflow design built in. A mulched area to help retain water. Pretty standard rain garden stormwater design. So we looked at one compost where we're trying to achieve a goal on site with some very basic parameters. And then the next step to that, to me, is the green roof world and what they do in green roof media. Where a lot of my education and concepts for this come is out of the green roof educational side. Green roof media is highly designed, highly engineered. I'm not saying that every front lawn needs that level of complexity, but if some of the principles that are applied to green roof design were applied to more standard soil practices, you'd be able to have a lot more consistent quality product and something more replicatable. The nice thing about green roofing, I'll touch on in a minute here, I can replicate it. If someone's got the specs for an extensive green roof, I can figure out the ingredients. If I'm in California, or if I'm in New York State, or if I'm in Florida, maybe I've got a great biosolids compost in Florida, maybe I've got a Class A Canby product in DC. I can back into the design based upon the fact that they give you parameters and standardized testing versus narrow material definitions. So another biosolids facility in New York State, small ASP facility in Oppinger's Fall area. A nice example of what you can do on a fairly standard biosolids scale. There are not a lot of fancy technology like a Canby process or an IPS. Aerated static piles with a blower under a building, making a very consistent quality biosolids Class A product. Yes, that's my artsy photo. I went black and white on a couple of these just to make sure everyone's paying attention. Got to do something to have a little fun. Basic screen, very simple compost process. So I'm not going to really dig into green roof media if you'd like to get into it. Technically a soil-less media because it contains less than 30% silt and clay in general. So if it has very little silt and clay, from a soil science standpoint, you call it a soil-less media. Think potting mixes, things like that. In theory, a lot of them would have very little silt and clay, so at least start out that way. You call it a soil-less media. I'll show you an example of a project installation up in Plattsburgh and how the biosolids got worked in there, and the organic media. Again, the compost provides the organic matter. One of the important things Charlie talked about, and he kind of really hits upon, is that organic matter is one of the crucial aspects of soil health, and that's what compost and biosolids product, that's the main thing that they provide. So here's that example of green roof media performance design. These are the specs. If you're going to call it intensive, that's an intensive. If you're going to call it extensive, that's an extensive. Plattsburgh was a single course extensive, fairly shallow, less than 6 inches of soil-less media depth. These are the parameters you try to hit, and they don't care if you hit that with 50% compost or 25% compost. You can't hit it with 50% compost because of the nutrient designing that they've got in there, but we're just having a conversation about designing a soil for end use. So these are their standard parameters. The test methodology isn't on here, but it's ASTM designed as well. These are just some standard ranges from the FLL guidelines, which is the German Green Roof Landscape, German Landscape Society. So when you get done blending those inert materials in compost, you get something that looks like this. Not necessarily the prettiest soil you've ever seen, but the performance design is what we're looking for here. Something that's going to provide nutrients, structure for those plants to grow. It's a very particular type of plant called a sedum. Rock plants is kind of the popular horticulture term. Low-growing, slow-growing plants that use very little nutrients. Here's their installation. It's a sedum mat. There's a couple other pictures coming up. These come in like tiles. You put it on top, trim the edges, it grows in place. You can see just bulk handle, dump material in place. Green roof media, it's an interesting biosolids product, interesting biosolids end use, not huge volumes. You know, standard green roof is probably less than 100 cubic yards of finished soil. Standard green roof media might have 25% compost by volume, 25 yards of compost at a time, but we all gotta get there one way or another. So here's some more pictures of that installation. Again, seeing where a biosolids product is used in a final performance-based situation as a stormwater management tool. So if we move away from that concept of topsoil, sand, compost, which most state DOTs just put out there for bioretention. I mean, New York State's bioretention spec for the DOT, 50% C33 washed concrete sand, 50% topsoil type A. That's literally it. Topsoil type A, the definition of that within New York State is as broad as you can imagine. So not a lot of quality control, not a lot of performance on the back end. To me, it's a major mistake, and I spend a lot of time talking to engineers and architects about coming up with better performance characteristics to carry through on specifications. You know, moving away from defining the materials to defining the results is the term I like. If we want to build performance systems, we have to define what that performance is and what the results should be. So this is my favorite out of Maryland. Any regulators from Maryland? The performance designs they have are very interesting, but they have 209 pages of stormwater management design, 1/2 page on the soils. So it's, these are some of the challenges that if we want to see the growth of biosolids product use, we need to be involved in things like this, because that 1/2 page defines tens of thousands of yards of potential places for biosolids to go. We talked about green roof media. We'll speed this up here. Common ASTMs. The interdepartmental issues is another big one. I think that if we're going to be looking at performance and lessons learned from soil designing, a lot of the environmental agencies within cities and states encourage beneficial reuse from, say, let's say their solid waste side of the equation, but then the water or environmental regulator side, we'll call it, gets concerned about nutrients and nutrient runoff. And instead of having an internal conversation of we want to see these materials reused and we want to protect water, everyone goes down their own path, and we end up with phosphorus regulations, like John pointed out, that are based on total P versus available P, and you end up stuck with products that might not fit for some of these specifications. So working towards common language is a big one I'm trying to promote. And if we're talking about ASTMs, those are things that we can all agree to. It's available to everyone. You can go out and pull them off the web at any time. So just some thoughts on performance-based design helping growth in our industry. Back to the biosolids in particular, where I think biosolids has some advantage, at least in the Northeast. California, I might give you a slightly different answer, but in the Northeast, the biosolids industry, the amount of regulation and testing that all of us are under is far greater than most other compost or organic amendment products. So having that data can be a benefit. Some engineers, some designers do appreciate that information and realize that if you're testing your compost or biosolids product weekly, monthly, quarterly, you have a lot more data than the average composter or farmer that isn't necessarily gathering that same level of technical information. There's also some benefits on the weed and pathogen front. That's a big concern on a lot of green infrastructure aspects. If we're going to build green infrastructure, you need to be able to guarantee that I'm only bringing in the plants I want to bring in. So biosolids products tend to have very good weed and pathogen kill because that's our concern. So touting that aspect of it as an end use, it could be a way to open some doors. Again, I'm just throwing out some suggestions. The high organic matter for a low to weight ratio is also another big benefit on the green infrastructure side, and things like green roofing especially. A lot of green roofing in the US is made with biosolids products. I don't think their industry would love to go around and tout that necessarily per se, because they walk a fine line, but dealing with so many different green roof firms, I can tell you a vast majority of their suppliers that are in the Compost Council are making biosolids products and using that in their green roof products because it's got very high nutrients, high organic matter, and a low weight ratio. So compared to a long leaf compost, that's a huge benefit when you're trying to make a lightweight blend. So very briefly, we kind of talked a little bit about what green infrastructure is, how we can use biosolids within it, a couple examples of performance specs, and glad to take any questions I can. My plant question. Yes, I am handsome. Thank you. Next question.
Is this a one-shot deal? Do you ever go back and refurb? I mean, they're low-growth plants, right? Or, what's the maybe life cycle? Do you have to?
There is a fertilization life cycle. So in theory, green roofing, let's talk purely on green roofing. The bioretention is a whole other can of worms. But on a green roof cycle, you should be fertilizing or going back into that plant at fairly regular intervals, 6 months, a year, year and a half. Plus there's a lot of water movement through those systems. So a lot of them are using conventional fertilizers on green roofs, so if someone wants to argue about P, let's really have that conversation when a conventional fertilizer gets sprayed on a porous media like that versus a 1/4 inch top dress of a compost. Or Maintenance is the biggest concern with a lot of green infrastructure. That's one of the biggest hurdles we're all going to have to overcome from an end use standpoint is the maintenance. This isn't a pump that's just going to run nonstop for 10 years and maybe need service every year. You oil some parts, do what you got to do. But a bioretention cell, a green roof, it's a much more regular service structure. But if it's built into the plan and built into the cost, it's achievable and done all over the place. It's just cost. No. Little hard to hear. I'm sorry with a fan.
What is the big driver for green roofs today? Is it stormwater management? Is it just?
Sadly, beautification seems to be the bigger driver on the green roof media side. I talked about an extensive project. Very little of the industry is actually extensive. That shallow, purely, let's call it stormwater management solution. Most of the work is what I call but what is defined as intensive, greater than 6 inches of depth. Meaning they're putting trees and shrubs and they're building a park 10 stories up, or a beautiful patio. If you look at a lot of the real estate and trade magazines, there's a great website called Curbed. If anybody ever seen that from Vox Media, Google that one. They talk a lot that people in housing, especially in the urban environment, are looking for beautification aspects, lifestyle. Is there a patio 5 stories off the ground